Did you know this is how supersonic planes break through the air? What you're seeing is a supersonic aircraft creating visible shockwaves as it collides with air molecules. As the speed increases, the angle of these shockwaves becomes sharper. At such high speeds, traditional wing designs generate enormous drag, so both wings must be tucked inside the shockwave. That's why supersonic aircraft use sharply swept back wings. This is the famous Blackbird, the SR71 supersonic reconnaissance jet. Its engines are unusually long, nearly half the length of the fuselage. The front looks like a sleek dagger, while the rear features a triangular wing. It could reach speeds of Mach 3.2, and to this day, no Blackbird has ever been shot down. Why? Because conventional jets and missiles simply can't catch it. On both sides of the fuselage are sharp edges known as chines. These create powerful vortices along the aircraft's body, generating about 20% of its lift and creating a low-pressure zone above the jet. Plus, the flat design reduces radar cross-section radar waves bounce away instead of back, making it harder to detect. Unlike the droplet-shaped wings on normal planes, the Blackbird's wings are razor-thin. That's because at supersonic speeds, the front edge of standard wings creates turbulence, the infamous sound barrier. Thin wings slice through the air, generating clean shockwaves that smooth out the airflow and maintain lift even while flying at over 3,000 km/h. The Blackbird's jet engine works like this. Air enters through a sharp cone at the front, passes into a compressor with spinning blades, mixes with fuel, and is ignited in the combustion chamber. The hot gases exit through the nozzle, spinning a turbine and producing massive thrust. The cycle keeps repeating. It's a self-sustaining jet propulsion system. To handle incoming air at Mach 3, the cone-shaped air inlet at the front extends and retracts to manipulate shockwave behavior. This converts supersonic air into subsonic flow essential for combustion. High-speed air is slowed down in exchange for pressure, density, and temperature, all crucial for efficient ignition. Nearly the entire Blackbird body is a fuel tank, except for the cockpit. It carries over 46,000 liters of fuel, weighing 36 tons. But at Mach 3.2, it burns 9.5 tons of fuel per hour. That's why aerial refueling was standard during its missions. In front of the main fuel tank are 4 nitrogen containers, an inert gas used to fill empty fuel spaces and reduce the risk of explosion under extreme conditions. The landing gear is unique too. The front gear has a steering system, while the rear gear supports most of the plane's weight and sits directly under the engines. The tires are made of aluminum-infused rubber, heat-resistant and reinforced and inflated, not with air but nitrogen, at 15 times the pressure of a car tire. The SR-71 flew above 20,000 meters for high-altitude surveillance and interception. It carried no weapons, only sensors, and its mission was data collection. Because of the altitude and speed, pilots had to wear pressurized astronaut suits. Developed in 1963, first flown in 1964, the Blackbird entered service in 1966 and was officially retired in 1989.